Okay, time spent on internet per day. They want the mean, median, and mode. So what should you do with this data? I would organize it first. What's the smallest? 43. Then what? Then 65. Then what? 68. Then what? 75. Then 95. Then 120. Then 140. 180. And 225. And I always double check to see if I have the same number that I started with. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're good. So how do you find the average? What do you do? Add those up and divide by what? 9. So let's all do it. 43 plus 65 plus 68 plus 75 plus 95 plus 120 plus 140 plus 180 plus 225. Tell me what you got.
112.
What'd you get?
112.33.
No, what'd you get for the adding part?
Oh.
1,001.
Did you get that number?
Yeah.
Okay. And how many did we say there were? 9? And what's your answer? 112.3. That's your average. Okay. How do you find the median? Well, since there's 9 is odd. Which number is going to be your middle number? Not that one, not that one, not that one, not that one, but 95.
If there's no repeating numbers, is there no more than?
Right. In this case, there's no mode. We see none. Okay? Next. Okay, I want you to look at 9 and 10 and tell me what you think. The outlier is very subjective. Does anyone see an outlier here
2.1.
for number 9?
9.8.
I would say 9.8 is, because if you organize these, the smallest number is 2.1, right? And then 2.3. Those are pretty close together. So I wouldn't say 2.1 is an outlier. But 9, it jumps from, here's 9.8. From 5.9 to 9.8, that's a pretty bigger jump than the rest. So I'm going to go with 9.8 as an outlier. How about 10? 0. This is your outlier right here. Okay, number 11. This question basically asks you to compare, if you were to write something about the temperatures, if you found the average temperature here and here, you would compare them. How do you find the average? You add them up and divide by, is there 12? Yep, 12. So, so you figure out the mean for Jacksonville and the mean for Austin, Texas. And then you would make a comparison. So the mean for Jacksonville if you add them up and divide by 12, you get 67.9. For Austin, the mean is 68.5. So you could actually say something that, the average temperature in Austin is higher than the average temperature in Jacksonville. Okay, and you do the same for mode, the temperature that occurred most often, and same with the median. You just compare them, which is higher, which is lower. Okay, I wanna get into these ones right here. How do you make a box and whisker plot? Okay, what's the first step? Organize the data. Let's organize it. And by the way, I'm gonna use a separate sheet because, actually no, I can do that on here. What's the smallest of the numbers? 11. And I cross it out after I use it. Then what? Looks like we have two 12s. Then what? 14. And then it looks like we have two 15s. Did it end again? Okay, two 15s. And then we have a 16. We have an 18. We have two 19s. And we have a 20. Okay, so our data goes from, I'm gonna say 10, let's do, let me do it on a separate sheet. Zero, 5, 10, 15, 20, 25, 30. Okay, there's our number line. Now, what you want to first plot is your smallest number, which is 11. It's your lowest number. Your highest number is 20. Now we need the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what's the median? 15. Here's your median. This is going to be called Q2. This is Q2. Now we have this lower half. What's the median of the lower half? Is 12. This is Q1. And then we have 19 is the median of the upper half. Here's your box and whisker. So just so you know, your lowest, these are all the things that you should know. Your lowest number is 11. Your highest is 20. The range is the difference of the highest and the lowest, which is 9. Your quartile 1, quartile 2, and quartile 3, these are all the medians. So the median of the lower half is 12. The median of all of the data is 15, and the median of the upper half is 19. There's one more you should know. IQR. That's called the interquartile range. It's the difference of these two. It's the difference of Q3 and Q1. What do you get? 7. That is a box and whisker. Try the next one. 13. So organize the data. What's the smallest number?
117.
117. Then what?
105.
It's 105.
Oh, it's 105. 105, my bad. 105, then 117, then what? 120? Then
130.
130, where's 128? Up, 128, then 130. Then 133. Then 136, and 145, and 150. Okay, so what is our lowest and highest number? Let's go from 100. Go 110. 120, 130, 140, 150, go to 160. Okay, what's your lowest number? 105. That's your smallest number. What's your biggest number? 150. Okay, now we need to find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gonna be 130, right? 130. That's your Q2. So the median of these two would be what?
19.1.
19.5. Q2 we said is 130. What's Q3?
140.5.
Middle of here, what is it?
140.5.
140. How'd you get that? Add them up and divide by 2. So 140.5. So what's our box and whisker gonna look like? Your box, here's your Q3. This is your box. And these are the whiskers. So 25% of the data is between this number and that number. 25% is here, and 25% is here, and 25%. What's the interquartile range? How do you find the interquartile range
Subtract the highs and the lows.
of the quartiles, right? 140.5 minus 118.5. So 140.5 minus 118.5 gives us 22. So there's 22 numbers between here and here. That's the span between the two, the lowest and the highest quartile. What's the range? What's range? Range is your highest, 150 minus 105. What's the range? 45 is the range. Okay? Okay, last set of problems. We're just gonna do 14 and 15. How do you find the 30th and 90th percentile? Okay, first we need to organize this data from least to greatest. Wow, we have big numbers here. So help me out. What's the, they didn't organize it for us. What's the smallest? No. No.
The last one.
The last one, I agree. 5581. Then what? 5700. Twice. I see two of them. Then we have a 5896. We have a 5993.
And then
Whoops. 72 was first. 5972. Then 50. $9.93. Okay, then we have, now we're in 6,000. The smallest 6,000 is
6,075.
6,075. 6,274. 6,283. 6,381. So if you were looking for the 30th percentile, how many numbers do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 items times 30%. What do you get? What's 10 times 0.30?
3.
3. So what is the 30th percentile of this data? It's this number right here. You're gonna count 3 in. So 5,700 is the 30th percentile. So 5,700 is the 30th percentile. How would you figure out the 90th percentile? You do 10 times 0.90, which is 9. So the 90th percentile will be this number if you count 9 in. So 90% of the data from here on is at 90% is at this number or below. 10%. This is 90% of the data, and this is 10% of the data. Last one, number 15. Okay, what's the smallest of these numbers? 1. Then up, we get a 2. Then we have, looks like 2 3s, right? 3, 3. Then what? I see a 4. I see 1 5. What else? 1 6. I see a 7. No 8s. 1 9. What else? Oh, there's another 9. What else? There's no 10. The next number seems like it's a 14. Hmm?
12.
Oh, there's 13. Where do you see 12?
Second one.
Next to the second one.
I'm blind. Oh, right there. So it went 9, 9, then 12, right? That should be a 12. Then we have a 13. How many 14s are there? 1. Then a 2 15s. A 16, 2 17s, an 18, and a 20. Now let's double check, see if we have them all down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18,
Excuse this
19, 20.
interruption. All track athletes attending the division meet should be released at this time. Thank you.
So we have 20 numbers. So if you're trying to figure out the 30th percentile, what's 20 times 0.30? Be 6. You're gonna count 6. 1, 2, 3, 4, 5, 6. This number from here down is 30th percentile. So 5 and below is in the 30th percentile. 5 is the 30th percentile. How would you figure out the 90th percentile? You're gonna look at the number 18. The 18th number, 1, 2, so it's this one right here. 17. So 90% of these numbers are 17 and below. 10% are 18 and 20. And that's it.
That's all I need you to do.